Okay, so I wanted to do just a video on factoring in case some of you needed that review. We gave you a handout in that chapter. It's yellow, it's on cardstock, and it's kind of a flow chart. It is a flow chart of different ways to factor based off the number of terms in the polynomial you're factoring. And so that's kind of what these notes are set up to do. First and foremost, you always want to take out a GCF. So no matter how many terms exist, you always look for a GCF. If the leading term is negative, then the GCF will also be negative. So if you look between these two terms, the GCF would be negative. Between 10 and 25 is 5. Since this has a to the fourth and this has a to the third, then they both have at least a to the third. So negative 5 a to the third is my GCF. I'm going to take it out to the front of the parentheses. And now my job becomes to come up with the two terms in here that if I were to distribute this back in, I would get back to my original problem. Because factoring really just means like undo multiplication. So negative 5 times 2 will get me the negative 10. I have 3 a's, I need 4, so I need one more. Negative 5 times negative 5 will get me back to 25. I need 3 a's, I have 3 a's, I don't need any more. And if you look inside, 2a and 5 have nothing else in common. If they did, then this technically wouldn't have been the correct GCF, or maybe I was trying to multiply wrong. If you look at example B, one of the things that you want to make sure you have is the polynomial in standard form. So we would actually rewrite this with negative 8x plus 4. Standard form means the variables from highest degree to lowest degree are in the front. So this is x to the first, and this is technically x to the 0. So this is the order we would put it in. Between negative 8 and 4, they have a negative 4 in common. And then same idea, come up with the two things that would need to be inside in order to get back to this. So negative 4 times 2 is negative 8. And then negative 4 times a negative 1 will get me back to that positive 4. So this is your completely factored form. When you have 4 terms, we call the factoring method grouping. So I'm going to take the first 2 terms and group them, and then take the second 2 terms and group them, and then I find GCF like I did here. So the GCF between 5a to the third and negative 10a squared is 5. They share at least 2 a's. So if I take out 5a squared, inside here I would have a minus 2. Now if I do grouping right, and I take out the GCF of this one, then I should end up with a minus 2 again. So these two share negative 4, and I end up with a minus 2. So I know I did grouping right when I come up with the same parentheses here. Now I rewrite this. So I have these two GCFs get to make their own group, so 5a squared minus 4, and then the parentheses that they have in common goes next. So this is completely factored form. If you look at the second one, first thing you want to always make sure is GCF. So these 4 terms didn't have a GCF, but if you take a look at all 4 of these, they have a GCF of 2. So before I begin my grouping, I'm going to take out that 2. So this becomes 2r cubed minus 6r squared plus r minus 3. And now I can do my grouping with these 4 terms. So I group the first 2, group the second 2. So between these 2, and I kind of ignore this until the very end. I just put it out in front when I'm done. I focus more on this grouping. So between these 2 terms, they share a 2r squared. If I factor that out, I get an r, just same way I did up here, and then minus 3. Now you always have to take out a GCF. Between r and 3, that GCF would just be a positive 1. I don't want it to change because I know that this was r minus 3, and I want that to be the same. So if I take out that 1, now I know that 2r squared plus 1 make their own group, and then r minus 3. And then don't forget about the 2 you took out at the beginning. So you know it's completely factored when you take a look at all of your factors, and within each one they have nothing in common. Another way we learned to factor was when there were trinomials. So trinomials are factored using that x. I'm going to actually remind you of a trick that we learned, but the trick doesn't apply when the coefficient in front isn't 1. So there is no shortcut on these two. You have to do the x and you have to take the x to grouping. So first double check no GCF. When you build that magic x, you take the first term times the last term. So we're looking for negative 30x squared, and then your middle term goes on the bottom of the x. Now what you're trying to do at this point is find two terms that multiply to this top number and add to the bottom. So 10x and negative 3x. Once you have those two terms, you're actually going to write this trinomial as a 4 term to use grouping to factor from there. So instead of writing this 7x, we're going to write it as a sum of 10 and negative 3x. So I have 2x squared plus 10x minus 3x minus 15. And then you do your grouping from there. So group the first two, group the second two. You've got a GCF of 2x here, and that becomes x plus 5. Negative 3x and negative 15 have a negative 3 in common, and that's how I'll get back to the x plus 5. So then this becomes 2x minus 3 times x plus 5. Again, they don't have anything in common within each set of parentheses. If you look at example B, 8, 26, 24, I've got x cubed, x squared, and x. So these actually all three have a 2x in common that I need to take out first before I even start the x. So if I take out the 2x, I get 4x squared. I also know the x method doesn't work right away on this because it only works for quadratics. If this isn't quadratics and I guess multiples of this too. So only certain types of trinomials. If I take out the 2x, 4x squared minus 13x minus 12. So now I've got something that the x will work with. And so if I build the x, and again, I'm just going to kind of ignore the 2x until I'm ready to put it at the beginning. If I ignore it and I look at just factoring this inside, I'm looking for two numbers that multiply to negative 48x squared, and then they add to negative 13x. So this one you might have to think about a minute, but it's negative 16x and a positive 3x. So this becomes 4x squared minus 16x plus 3x minus 12. And I do my grouping method from here. So group the first two, group the second two. These two actually have a 4x in common, and I can say that's x minus 4. These have a 3 in common, and that's how I get the x minus 4. So now this becomes 4x plus 3 times x minus 4. And then I bring down that 2x I took out at the beginning. So this is completely factored. Okay, so this trick is going to be super important. That's why it says use the shortcut. You're going to want to use this a lot when we start the next chapter on rationals. This shortcut only applies when the trinomial has a leading coefficient of 1. So if it's x squared or p squared or m squared, there's no number in front of that term with this squared, then this is the only time it will work. So if you think about coming up with your two numbers, you really only have to do the x for these. So if you're looking for two numbers that multiply to 25x squared and add to a negative 10x, those would be negative 5x and negative 5x. Well, the shortcut is using those two numbers to create your binomials. So because it's x squared, I know my two binomials are x minus 5 and x minus 5. If you don't believe me, you can take a 2 by 2 box, multiply that out. It will take you back to x squared minus 10x plus 25. So same goes with this one. I noticed that it's just p squared. So I'm looking for two numbers that multiply to negative 12, but they have to add to a negative 1. So that's negative 4 and 3. So if this is a leading coefficient of 1, then I know that this is p minus 4 and p plus 3. Again, you can multiply it out and double check it. Differences of squares follow certain patterns. So when there's two terms and there's not a GCF, then it's always good to ask yourself, are these perfect squares? Because if they're perfect squares, then they come from two binomials, just opposite signs. So you just have to find what are these values before they became perfect squares. So 49x squared and 16 are perfect squares. It's a subtraction, so this is a difference of squares. So this comes from a binomial times a binomial with opposite signs. So these a and b values, are 49x squared, came from 7, because 7 squared is 49, so this would be 7x. And then 16 is a perfect square, it comes from 4. So this is what it would look like completely factored. 9v squared and 25, both are perfect squares, no GCF, so I know it comes from two binomials, opposite signs, and then I just have to think about like what's the square root of each of these. So 9v squared comes from 3v, and 25 comes from 5. So it's 3v minus 5 and 3v plus 5. When it's not in standard form, so like on the bottom, you just put it in standard form and you apply any of the methods we've already talked about. So if I have negative x squared plus 1. So the first thing I like to do, or you have to do with polynomials, is anytime that leading term is negative, always take out the negative, even if they have nothing else in common. So if I take out the negative 1 from both of these, this becomes x squared minus 1. Now you'll see you can actually keep factoring this. This is a difference of perfect squares. X squared comes from x and 1 comes from 1. So this becomes x plus 1 and x minus 1 with the negative 1 you took out at the beginning. If we rewrite example B in standard form, we want highest exponent to lowest, so this would actually be negative n squared plus 5n plus 6. So the only thing that I need to take out is I don't want that leading term to be negative, so I'm going to take out a negative 1 from all three terms. So it becomes n squared minus 5n minus 6. Now I'm going to factor this inside, and I can use the shortcut since this beginning term is a leading coefficient of 1. So if I set up my x, I'm looking for two numbers that multiply to negative 6 and add to a negative 5. So that would be negative 6 and a positive 1. So if I know my leading term is just n squared, then my two binomials will be n minus 6 and n plus 1. And then don't forget you took a negative 1 out at the beginning. So this is your completely factored form.